So in this video we're going to be talking about geometric series, and the definition of a geometric series is the indicated sum of the terms of a geometric sequence. So if we recall properly, a geometric sequence goes something like this: 2, 4, 8, 16, 32, where each subsequent term is multiplied by a common ratio. In this example, it's multiplied by 2 to get to the next term. A geometric series is when you take a set amount of these terms or an indicated amount of these terms and add them up together. So we can say that S2 would be equal to 2 plus 4, and S3 is equal to 2 plus 4 plus 8. So that would be a geometric series. Let's look at the formula that for a geometric series. We can see that the formula here is Sn, the sum of the first n amount of terms, is equal to a times r to the power of n minus 1 divided by r minus 1. And it's important to know here that r cannot equal to 1. So let's explore the variables. We have Sn, which is the sum of the first n terms, n, which is the number of terms in the series, a, which is the first term in the sequence, and r, which is the common ratio. And if we recall properly, the way we find out r is by dividing two subsequent terms. So let's look at our first example. Let's copy it into our program. Let's move it down. Alright, so for a given geometric series, T2 is equal to 21 and T3 is equal to 63. Find the sum of the first 5 terms. So the first approach to solving this problem would be to define each term in terms of its formula. So we know that the formula for a geometric sequence is Tn is equal to a times r to the power of n minus 1. So if we take this, we can say that we know T2 and T3, so we can use either one. So let's use T2, smaller numbers. So T2 would be equal to a multiplied by r. So as mentioned before, r is found by taking two subsequent terms of a geometric sequence and dividing them by each other. So T3 and T2 are two subsequent terms, so 63, which is T3, divided by 21, which is T2, is equal to 3. So that is our r value, our common ratio. So a multiplied by 3 to the power of n minus 1. So since this is the second term in the sequence, n is also going to be 2, and 2 minus 1 is 1, so 3 to the power of 1. And we also know that T2 is equal to 21, so we can say that 21 is equal to 3a. And when we divide both sides by 3, we get 7 is equal to a. 7 is the first term in the sequence. So using this, we can take our formula for a geometric series. Let's review that quickly, which is Sn is equal to a times r to the power of n minus 1 divided by r minus 1. Let's copy that into our program so we have it at our control. So if we take this and substitute our values into it, you get Sn, or it's asking us for the sum of the first 5 terms of the series. Yes, the sum of the first 5 terms. So S5 is equal to a, we found out was 7. 7 multiplied by our common ratio is 3, so 3 to the power of n we already mentioned was 5 minus 1 divided by r minus 1. And I'm just going to put this into my calculator, you can follow along. So 3 to the power of 5 is 243 minus 1 is 242 multiplied by 7 gives me 1694. Divide that by 2, I get 847 as the sum of the first 5 terms in this series. Let's check that with the correct answer. And we are correct. The sum of the first 5 terms is 847. So now let's look at a counterexample, a way to do this incorrectly. So copy this. So this question is asking us to create a geometric sequence and find the sum of the first 5 terms. I must have missed the S. So find the sum of the first 5 terms. So let's again recall the formula for a geometric sequence, which is Tn is equal to a r to the power of n minus 1. And most students here would be tempted to put r as 1 because they like small numbers and 1 is the simplest number you can work with. So they would be tempted to put a multiplied by 1 to the power of n minus 1. And this is a perfect example of a wrong answer, because if we go back to our PowerPoint, we can see that the formula for a geometric series mentions that r cannot be equal to 1. Now, why exactly is so we can see that r cannot be equal to 1 because if we go back to our formula here, what would happen if we multiplied every single term? Let me just write that again. What would happen if we multiplied every single term by 1? So it wouldn't matter what this exponent would be, because 1 multiplied by anything by itself, how many ever times, would always be equal to 1. So the you would always get a as the term. So your sequence would look something like this. And also, if we look at the formula here, we get r minus 1 as the denominator. And as we know, anything that makes the denominator equal to 0 is not valid, and it goes against the laws of math. And if r equals to 1, we can see that 1 minus 1 would fully equate this equation to 0. So to solve this problem, we need to make r, the r value here, makes equal something different. So let's say Tn is equal to a. Let's make r 2, which is the next easiest value, to the power of n minus 1. Again, for this, we can make a equal to anything, and here it's quite alright to make a to be equal to 1, because the next term would be different. So let's say we're looking for the second term. So T2 would then be 1 multiplied by 2 to the power of 2 minus 1 is 1, is equal to 2. And again, we're multiplying each subsequent term by 2, so we can just easily get the formula from that. The sequence from that. 2, 4, 8, 16. And there we have our geometric sequence. Now it's asking us to find the sum of the first 5 terms. Again, you can just add these 5 numbers to get the sum, but for the purpose of this video, let's use the formula. So again, we have Sn is equal to a Rn. Just copy that. Sn is equal to a Rn minus 1 divided by r minus 1. So here we're looking for S5. S5 is equal to a. We know that a here is 1. Multiplied by r, we know that the common ratio between the numbers is 2 to the power of n, but we know that n is also equal to 5, so this should actually be 2 to the power of 5 minus 1 divided by the common ratio again, minus 1. So the sum of the first 5 terms would be 2 to the power of 5 I have is 32 minus 1 is 31 times 1 divided by 1. So the sum of the first 5 terms is 31. Now let's double check that with our answer. We have 1 plus 2 plus 4 plus 8 plus 16 again gives you 31. 1 plus. So again, the important thing to note from this counterexample is that when given this kind of question, when given this type of question, you should never equate r to 1 just because it's a small and easy number, because you will get a wrong answer, or you will get an answer that's not valid. And that concludes our video. Thank you for watching.